Our next talk is called Supercharge the Speed of Your Apps with these Progressive Web Application Secrets by Marta Wiśniewska. Marta is a Google developer expert in Angular and web technologies from Poland. She is international speaker, blogger, enthusiast of Angular progressive web apps who loves exploring new web features and following hottest web trends in tech. Marta is passionate about sharing knowledge in the community and spreading her love for tech. Besides that, she loves coffee, sports, dancing, and traveling. So everyone, welcome Marta.
Hi everyone.
Hello there, how is it going?
Good, thanks, and you?
Yeah, also nice, thank you. So how is it like with this travel thing? I guess it's not really working out this year, huh?
But maybe, hopefully, the next year will be much better.
I see that. At least the coffee tastes still good. So without further ado, we should jump right into the topic so that people can learn something about the progressive web applications.
Yes, let's get it started. Hello everyone. My name is Marta and I'm super excited to be a part of this conference. I am a huge fan of progressive web apps, and today I will tell you how you can supercharge the speed of your app with these progressive web app secrets. And even if you're not familiar with PWA but you want to get some knowledge about web performance, the presentation will be useful for you as well. Let me introduce myself. My name is Marta Wiśniewska, I'm from Poland, I live in Warsaw, and I'm a Google developer expert in Angular and web technologies. I work as a front-end developer at NES in Warsaw, and I'm a huge fan of open source, Angular, progressive web apps. And I co-create open source project called PWAA. If you want to start your journey with PWA, you can find us on Twitter, or you can visit this page, pwafire.org. I love all things about tech. I also love coffee, sports, and community. If you will have any questions after the presentation, or you want to be updated with PWA, Angular, and front-end technologies, you can find me on Twitter. Oh yes, we need to talk. A few words why I selected the topic. Well, actually, I follow content about progressive web apps, different talks, blog posts, and so on. And still, I can see that there's a lot of different approaches to this technology, opinions, and also a lot of misunderstanding. For example, how to qualify app to being progressive. Because sometimes people think that if they are able to add icon to home screen, they claim that this is for sure progressive web app. But it's not sure. Not true, because the main requirement for progressive web app is a service worker. And until you can't verify that this is active, then you can't say that this is for sure progressive web app. And a lot of time I heard about different approaches regarding business side, about benefits because of user experience. But I was wondering what would be useful for you as a developer, and what is the most universal pro of progressive web apps. I think this is a web performance. So progressive web apps allows you to make your app faster. But it doesn't mean that if you apply service worker, then you improve all your performance metrics. And today I will tell you what does make your app faster, what are techniques and architectural patterns that allows you to improve web performance. Let's take a look at the agenda. I will start with caching strategies and design patterns to boost progressive web apps performance. Then I will tell you a bit about the combination of progressive web apps with WebAssembly. So that are progressive web assembly apps. And last but not least, I will tell you about my performance tests I did on 15 progressive web apps that are in production, and will show you the most common issues and also give you some tips how you can avoid them. Let's get started. I will start with caching strategies and design patterns to boost progressive web apps performance. Well, caching is the main source of making progressive web app faster. And before we started using progressive web app, we're also talking about browser cache. But the main difference in cache that Service Worker offers is that you have better control over how your assets are managed. And the Service Worker is the heart of progressive web apps. This is the proxy between client and server. And from practical perspective, this is a JavaScript file that is registered in your browser when you open it for the first time. It provides a persistent medium to keep network requests in controllable cache. You're able to control and to cache your scripts, other pages, images, assets, and so on. And it allows you to cache your resources and to make your app faster. You don't need to wait for server response. You can get some resources from cache. It may, but also may not. So it will for sure eliminate any potential time to first byte issue. But please remember that caching only matters after the first page is loaded. So you can get faster load time on repeat visit. But even if the service worker is active and you have pre-cached all pages responses locally, it doesn't guarantee the page render fast. It only means that the network requests are returned from the local cache. And there is a great tip. Run audit tests before caching. Because if your app is heavy, for example, you have a lot of JavaScript, it just will take longer to render and service worker won't help you. So please remember, remove unnecessary JavaScript, CSS code, libraries, dependencies, and also optimize your assets and images. It will help you because if your web app is light, then you will create fast, progressive web app. So let's talk how you can cache your app. I will tell you about caching strategies and design patterns that you can apply to your progressive web apps. And before I will do that, we should consider two factors and answer two questions. And the first one is, where does the data live? Basically, you have two options. You can get data from cache, or you can retrieve it from network. And based on these options, you have different caching strategies. And the first one, it was really common before progressive web apps, that we only retrieve data from the network. So we use network requests and responses, and just based on that, we use it in our app. Progressive web apps and service worker allows you to use cache and just retrieve data from cache. And one strategy is just using only cache. So you don't use network requests and responses, but you only try to get it from cache. But from practical perspective, we use a combination of network and cache. And one option is to use cache first, network fallback. This is a strategy where we try at the beginning to get data from cache. And if we can't do that, then we will try to get it from network, and then we send a request to the server. And in the opposite side, we try to get data from the network at the beginning. So for example, the most meaningful for us is to have fresh data and fresh app. But if we can't get this data, for example, because we don't have access to the internet, then we try to get it from cache. So it's just alternative just in case. And the last option, this is cache network race. So at the same time, we try to get data from cache and from the network, and we use that one that is delivered faster. So it was the first question. And the second question is, how do you render the app? Currently, you have two options. You can use server-side rendering or client-side rendering. In server-side rendering, we will generate the full HTML for a page on the server as a response to navigation. But in client-side rendering, we will render pages directly in the browser with JavaScript. And all logic, data fetching, templating, and for example, routing are handled on the client rather than the server. Based on these two kinds of apps, we have different caching. So we can apply caching on the server side, and also we can use it on the client. Caching server render apps is simple. We just cache the static parts. That can be CSS files, JavaScript frameworks, and some images. And it's really fast and simple to do, but it's really hard to create effectively working offline apps because the server just returns the whole page. In client-side rendering, we will cache core code, CSS, and template, but we also have to add some code to handle, let's say, dynamic data. And basically in client-side rendering, we use cache API or index database. And the general idea is that the things with URL go in the cache, but non-URL data goes in database. So how to select the best solution for your app? Well, the best option is a mix of server-side rendering and client-side rendering, but we can also apply to different parts of your app. So let's take a look at this combination that we try to divide our app into the static parts. We call it the app shell model, that are components common to all pages, typically involved with navigation. And also you have the more dynamic parts. This is content, that are parts of your app that changes when you navigate in your app. And the best option is a combination of server-side rendering and client-side rendering. So the server can draw the first page quickly, and then we use JavaScript and render future pages using dynamic data when we will navigate in this app. So this is the best option, the fastest apps you will get. But you can also apply the pure app shell model. So you can use caching on the server side and don't use caching for fetching content because we'll only use JavaScript to do that. And it's really useful solution if your app is, let's say, quite dynamic. If your content change a lot, they will be really difficult to create fresh and fast app. But if you still want to update the data in your app, it's better don't cache it. Only cache the app shell. And the third option, we will use server-side rendering for both, for the app and for the content. And we will cache everything that we can. And this option is great if you have static app. And server-side rendering and caching on this side is really fast. But what I told you before, it's hard to create good, effectively working offline app because it can handle some cases for some dynamic data. And finally, we will have caching only on client side, and we will cache both the option and the content. And it's quite common option, but it's often slower than server render apps. And the main reason is that it takes time to load the JavaScript before rendering begins. So that are the main options for you when you design progressive web apps. Let's switch to another topic. I want to tell you about the combination of progressive web apps with WebAssembly. And I'm a huge fan of mixing technologies. And I found this solution when I was trying to combine two hot trends in web performance. This is WebAssembly and progressive web apps. And maybe the idea seems to be a bit abstract at the beginning, but please keep calm. I will introduce you and I will tell you the main concept in a few slides. So progressive web assembly apps are the combination of progressive web apps and WebAssembly. And today I tell you a bit about progressive web apps because of web performance and about profits if we're talking about loading time. But why we want to use WebAssembly? Well, basically JavaScript right now is the only option to build front-end apps. And JavaScript is really universal and powerful programming language, but also have some cons. And the most important is that it's quite slow. And we know cases that we will never choose it as a solution. Because sometimes we just need more than JavaScript offer. And in many cases, WebAssembly can do the same task, and also it will outperform JavaScript. So that's why we sometimes can replace JavaScript with WebAssembly. So how you can use it, the WebAssembly with progressive web app, and how does the WebAssembly work? Well, let's assume that you have a front-end app and you have some part of your app that you prefer to write in another programming language. It can be Rust, C, or C++, because it just will be more effective for you to create it in this language. So we'll compile this module into WASP module. And on the front-end side, we will have our JavaScript app with some JavaScript libraries. Let's say, for example, this is progressive web app, so we will attach service worker, we will add web manifest. And to integrate this WebAssembly with progressive web app, we will add WASP module to your app. And the last step, we will just serve it in a browser. So browser will execute WASP binaries into a virtual machine. So this is the general scheme. I hope you get how it works. But if you're looking for a more practical solution, so this is generator for Rust, WASP project. So it allows you to write the entire app in Rust, but also it allows you to use typical progressive web features like service worker and web manifest and so on. And it just combines all good things of these both technologies, or service or WebAssembly and progressive web apps. And you can find here the official link to this project. This is was.sh. And also, if you want to get source code, here you can see the link to repo on GitHub. All right, so this is the last part. Now I'll tell you about my performance tests I did on progressive web apps that are in production. And a few words about the experiment. Well, I used Measure tool from web.dev platform, and I tested 15 progressive web apps that are in production. And here you can see the main overview. I listed issues and with counters how many times the issue appeared. And today I will focus on the top 5 I will tell you how you can avoid these common issues and also some tips how you can easily improve loading time in your app. And I highly recommend you to try this measure tool from web.dev. This is based on Lighthouse, and it allows you to test any web app that is in production that is served on a remote server. And it gives you a great overview about performance metrics, and also what is, I think, the most useful, it gives you tips for your typical progressive web app or web app. So it gives you, for example, that you can replace those images, or you should avoid this file in your app that is longer, and so on. So let's try if you need any tool and you want to use performance metrics and you want to improve it in your app. And the first, the most important problem is critical request chains. We should avoid chaining critical requests because these chains are a series of dependent network requests important for page rendering, and they significantly have an impact on the page load performance. So you should minimize the number of critical resources. You can eliminate them, defer the download, or mark them as async. We should optimize the number of critical bytes to reduce the download time, number of round trips. We should also optimize the order in which the remaining critical resources are loaded. So we should download all critical assets as early as possible to shorten the critical path length. The second tip, keep request counts low and transfer sizes small. So we should analyze requests and resources in your app. You can analyze the number and the transfer sizes. And there's one option that you can add budget.json file and sets budgets for specific metrics. For example, you can set a limit for a first meaningful paint, or limit for overall size of the page, or the number of requests, and so on. So I highly recommend you to try use it in your app. The next issue is involved with the browser's render process that mainly turns your code into a web page that users can interact with. And by default, the main thread of the render process typically handle most of your code. It parses the HTML and builds the DOM. It parses the CSS and applies the specific styles. And also it parses, evaluates, and executes the JavaScript. And here you can see these processes and also time that the browsers need to run it in your app. And the most meaningful, as you can see, this is the script evaluation. So I will focus on that one and I will tell you how you can improve it. So the main thing that you can do to minimize the main thread work is to deliver smaller JavaScript payloads. And one option is to use code splitting and to send code that your user needs at specific time, not to send the full code. The other option is to cache your code, and there is great PRPL pattern. It means push, render, pre-cache, and lazy load. And the main idea is that we start with pushing the most important resources, then we render the initial route as soon as possible, then we pre-cache remaining assets, and at the end we lazy load other routes and non-critical assets. So that's how works this pattern, how you can use it for your code to minimize the main thread work. But also really important that you should minify and compress your code and also remove unused code. And to the last one, I have a tip for you with Chrome Developer Tools. If you add additional tab called Coverage, then you will get listed files with unused bytes. So you can filter these files and find that one that have the most code that is, let's say, unuseful for your app. Because if you open it, then you will get sections that you don't need, that are just unused in your app, and you can easily remove them, and in this way you can just improve the loading time. Another super important topic, this is deferring off-screen images and also iframes. So we will trigger image load using JavaScript events, and now you have the option to use native lazy loading for images and for iframes, but also you can implement it on your own with intersection observer API and with JavaScript events to trigger image loads. And regarding the option of native lazy loading, let's take a look at browser support for this feature. Well, basically, now it's possible to use in Chromium-powered browsers. It is Chrome, Edge, and Opera, and also now in Firefox nightly version. I tell you about the images when I'm talking about web performance, because here you can see potential saving that you can get from only applying some ways to improve the web performance. And for example, with lazy loading for images, you can get even 18 seconds. With properly sized images, you can get 17, and with converting typical formats into next generation formats, you can even get 14 seconds. So as you can see, this is a great score. So let's take a look what we can also do except of lazy loading. So what I told you before, this is a way to improve with sizes and also with formats. Regarding sizes, we should never serve images that sizes are bigger than renders on the user screens. And regarding formats, the best are vector-based images. So it's mainly SVG, and also we should remember about replacing complex icons with SVG. And also we should replace traditional formats like PNG and JPG with next generation. It can be WebP or JPG 2000s, because those formats have better compression and quality characteristics compared to JPG or PNG. And you have also great tools that allows you to automate the process of converting multiple images into another formats. And these tools are gulp responsive or responsive images generator, and you can easily find them on GitHub and apply it in your console. Then you can easily convert multiple images into, for example, another next generation format. Let's sum up. Today I told you about ways how to improve the performance of progressive web apps. That caching is the main source of making your app faster, but please remember that this caching should be reasonable. So please consider a few factors I told you today about designing progressive web apps. Please remember about audit tests before caching. It can be really meaningful for you. Please take a look at the combination of WebAssembly with progressive web apps. Maybe it makes sense to apply WebAssembly into your app to make it faster. And the last one, and I think the most important, keep in mind that the same performance metrics for web apps are great for progressive web apps. Because fast web app means fast progressive web app. And that's all from my side. This is the link the full presentation. If you have any questions, I am free to answer. And thank you a lot. Have a nice day.
So thank you for the great talk, Marta, and all of those actionable tips. I hope like everybody will take them to heart and try to apply them to their progressive web apps if they are building them. So thank you again. And we have already a couple of questions like in the chat, like from the people. So there is one question from Mattia. How come that the cache network race is a valid strategy? Shouldn't the cache always respond faster than the network? In what kind of situation the network would respond faster than the cache? So I guess it's like about the use case for this like race strategy, which you described like in the beginning or like the first half of your presentation, right?
Yes. So it depends how much do you store in your cache and how does your server respond. Because if you're not sure what your user is trying to get your data, then you don't know which strategy it's good to apply. So it's for mixing those strategies if you're not sure which strategy would be better for this user at current moment. But to be honest, I have never used this one. And when I was trying these different solutions, it depends, of course, on the kind of your app, but I have never used this. So yeah, it's just an option for you. It's good to know that this exists.
Exactly. Like it's always good to know like all the options which are on the table, because what if like this kind of use case pops out and then you know like, actually I'm covered and I can't do it. So
yeah,
it's
and
never
I highly recommend you to verify how it's implemented already, because it's for sure in Workbox, and just to try the strategy and just to read the pure JavaScript. And I think it will be the best option to check what to exactly do.
Thank you for the answer. Then we have another question from Jan. So it's basically about like, how does the WebAssembly benefit PWA performance, as the WebAssembly does not have access to the DOM or the network APIs except Canvas context. So it's basically only beneficial for computation intensive purposes. WebAssembly does also come with lots of glue code and pre-initialization stuff. Does the benefits really rectify the overhead? That's a bit longer one, but let's try.
But I'm not sure if I catch the question, because I think that the question is about if it's worth it to use this WebAssembly. Cool. So I think that what you say, that it's only in a few cases WebAssembly is good to apply, and what you wrote about the huge computations, this is for sure. So actually, it allows you to mix both. But if we're talking about web performance, it's mainly more benefits from WebAssembly. But if we want to mix another progressive web features, not exactly the features that make this app faster, there is a good combination.
Okay, I see. So thank you for the answer. Another thing which I noticed like in like earlier parts of your presentation was when you were describing basically like this service worker that like it helps more like for the, or like the caching using the service worker helps more like for the repeated visits once you already cache, right? But it doesn't really help like with the first visit so much, because it's still all this caching has to happen. But my question was like, what is like kind of like the real world cost of like initializing the worker for the first visit? Is it something which can actually impact like this first visit? Like,
yes, for sure, because service worker is also JavaScript, and this additional file to to this all actions for service worker to run in your browser, so it's also costful. And when I was testing some progressive web apps, sometimes the first launching of this page was even slower than without running this service worker. So it only sometimes can help you, but not every time.
are there like maybe some strategies of how to initialize service worker like lazily, like well into the first visit or something? Like, is there like some best practices for that, like to how to postpone this so that you don't harm like this first visit experience?
So to be honest, I don't know any strategy yet.
I see. It's
So
like
it's
that.
just, I think, testing and trying.
Yeah, I mean,
Like
yeah,
in programming, in
that's
technology
true.
at all.
And Yeah, exactly. Because like when it comes like to like real life scenarios, like as you like show like these other tools where you can actually really analyze your deployed application to get like all these metrics, because it's never really the same like doing it like and in the dev like compared to like a real life scenario with all the stuff coming together. We have another question from Tommaso. Image having a logistic data entry. What? Oh, logistic data entry Angular application that you need to serve on the desktop and at the same time on the mobile Android devices. You have a continuous data entry and concurrent user viewing a list of entered data persisted to database. Is cache worth in this case? So if I understand correctly, we have some application which kind of supports like some concurrent data entry, which is kind of like real time for both like the mobile and the desktop. And it's like involving images. And if in that case, it would make sense to like do this kind of caching like with service worker.
Yes, for images it's good to, it also depends on the sizes of these images and depending on the device. But in general, for images, this is the best option to cache it. But it also is good to, to deliver a low sizes images. Like it's good to optimize before you start to cache it.
So could it be somehow like this, that like we could somehow like notify the worker like ahead of time to like pre-cache some images which we know that the user will need like soon or something? Is there like some way to do this, like from like access like the worker from the server, or like worker could be polling server all the time for the new data or something like this?
So we're able to check it from time to time if you're talking about this, or just analyze the events inside your Angular app or JavaScript app.
I see. Thank you. So I hope that Tommaso is satisfied. Okay. Another thing which comes to mind is like when we're talking about like these critical chain like resources which can like load each other, right? Like during the startup. And you said like you can basically analyze it like with this web.dev like tool which is there online where you provide like the productive URL. Is this something which can be also done like during the development time? Like is this tooling available just to like run it as a part of like your pipeline or something? Like
I'm not sure. I don't know which tool can be used. But it's, for example, you can apply the batch.json file to your app and then set some metrics and check limits that if they're proper for your app.
Okay, thank you. So do we have some more questions? Let's see. No. Okay, so then in that case, thank you again like for your talk. I hope people go like
Thanks so
inspired
much.
to try the stuff with the PWA to improve like their performance and like
Yeah, if you have any questions after you remind something, then write me in a private message on the chat. I am still here.
Perfect. So thank you again and wish you a great day. See you.
Thanks,
And
see ya.